Okay, welcome to our talk. I am Donato Ferrante, and together with my colleague Luigi Oriema, we're here to talk about multiplayer online game security. You may know our company. We work for Revolve. We provide several services, including consulting and vulnerability research. This is our agenda for today. We basically have three main areas to cover. We will first talk about, quick introduction about multiplayer game security. Then we will discuss how to find vulnerability inside multiplayer games, and we will disclose to you 0 days. And then at the end, some final consideration. So multiplayer games are a really interesting field for security, especially if you think about games as possible attack vectors and player as possible targets. Basically what you have is that you have thousands of different possible attack vectors and millions of possible victims. So the first question that we are trying to answer is why games? To do that, we are going basically to define two main categories, victims and attackers. Since we are talking about games, we basically have two main categories of possible victims. We have players, people that play games, and company, people that, they use game for, making money. So for each of them, we have different attacker subsets. Let's take a look. So for players, we basically have two main families. We have script kiddies. You may know them. They are people with no knowledge about security, no skills. They basically download tool from the internet, and they basically run this tool just for fun, and they crash, games for players. And then we have the rest of the world. The rest of the world include a lot of people with different, ideas about, and different targets. Think about, for instance, malware authors that are trying to spread, their new malware by using games as possible vector. It's more interesting to take a look at companies, because for companies, again, we have, script kiddies, because they are everywhere, and they basically don't care about, the target. They just do that for fun. But the most interesting category here, it's given by competitors, or if you want, other companies. The logic behind competitor, or if you want, company versus company attacks, is basically that they want to prove that their product and their service is better than the one provided by another company. Basically, the base idea, it's pretty simple. The basic logic here, it's pretty simple. The more a company is bad, the more another company will be good. How do they prove that? Basically, what they do is basically attacking competitor networks, which means clients or servers. Think about using denial of service attacks against servers of, a competitor. If you prove, that the network is not that great, not that good, do you think that player will still play on this game, on this specific network? We don't think so. So the first important point is never feel safe while you play online. It's always a danger. So in the following slide now, we are going to show you a couple of possible scenarios. So we will start with a client-side attack. In a client-side attack, the basic idea is pretty simple. We have a player enjoying his game on a server, and what happens here is as soon as an attacker shows up, the player here becomes a victim. So what we are going to show you here, it's just one of the possible scenarios. So in this case, the attacker first gets some information about his victim. In this case, think about, the IP address of the victim by sending a query to the server. And after that, basically, the attacker exploits a server-side vulnerability. Once the attacker exploits this vulnerability, basically the attacker has control over the system of the victim. This is a very simple attack scenario. The next one is more interesting, and we are covering the server-side attack. In a server-side attack, usually we have several different players playing an online game. In this case, again, we have an attacker that in this case exploits, a vulnerability server-side, and it takes control over the server. In this case, the attacker has two options. The first option is to go back to the clients. So basically, we go back to the previous scenario, but we have more targets. The second option is very interesting, especially if we are talking about MMO games. If you're a player, you probably know that for this kind of games, we have usually an in-game market where you can buy, in-game items by using real money. So usually you have to provide your credit card information. So usually from the game server, you can reach in some way internal database storing sensitive information. So the second option for an attacker is basically navigating through the infrastructure in order to reach sensitive information, to steal information basically. So at this point of the talk, we know about possible victims, we know about possible attackers, we know how they interact, but there is still something missing. What we need to understand now is how attackers get vulnerabilities. There are two main approaches. The first one is, they can just go on the market and buy vulnerability, and the second one is to find vulnerability. So, as you may know, there is a vulnerability market for even for games. And this is quite interesting and quite difficult, quite different from the usual market. On this market, basically, we are very interested. The people on this market are usually very interested in just zero-day vulnerabilities, and this is due to the fact that if you think about MMO. Usually, as soon as a new update of the client comes out, you need to update your game client if you want to keep playing on the official server. So this basically reduces the value of one-day vulnerabilities. Another important point about this market is that usually denial of service attacks are very, very valuable, especially for companies that want to use approach like the one that we were showing before. So if you're wondering about who are the people on this kind of market, this slide will give you an idea. Basically, we have players, we have script kiddies, we have server administrators, and we have a lot of companies. And we may actually have even additional people that show up on this market when they need to hit specific targets. Okay, so in the following slides, we are going to detail one of the possible approaches to find vulnerabilities in game. So, in order to find vulnerabilities in game, we usually need three things. The first thing is we need a game. Without game, basically, we cannot do anything. And then we need a debugger and a disassembler. This is because usually we deal with, binary programs, so we don't have the source code, so we need this kind of software. And the third thing, it's one of the most important. Since we are dealing with network-based game, we need in some way to be able to monitor the network traffic. In order to understand the value of the vulnerability that you may find inside games, it's interesting to understand the concept of game engine. A game engine is basically a piece of software that provides several functionality to a game. Basically, think about the game graphic, the sounds, the network interaction, and stuff like that. The most interesting point here is that usually a game engine is shared among different games. So if you are lucky enough to find a vulnerability inside a game engine, this vulnerability will be very valuable. And this is due to the fact that the game engine is usually shared among different games. So if you find a vulnerability inside a game engine, you are very likely to be able to exploit the same vulnerability across different games. Okay, so this is our map. And we're going to start by detailing custom protocols. As you may know, for performance reasons, usually games go over UDP. But it's not just using UDP and that is. Usually they tend to use the implementation of the TCP over UDP. So when we are dealing with this kind of protocol, we can see that the packet that we are going to analyze, it's very different from just a simple UDP packet. And this is due to the fact that we have a lot of additional information coming inside the packet itself. An interesting point regarding this TCP over UDP implementation is given by, if you want, a structure called fragmented packet. Basically, a fragmented packet is just a UDP packet, which basically constitutes the base unit of a TCP over UDP implementation. Usually, these fragmented packets are composed of three main fields. The first field is the position field, which basically specifies the position of the current UDP packet inside the TCP stream. The second field is the size of the data contained inside the current packet, and then we have the data itself. To get a better understanding about the fragmented packets, please consider this slide. We have the original packet on the left, And then we have the fragmented implementation of this packet on the right. As you can see, for each packet, we have a different header specifying the three fields before. So as soon as the game engine basically gets each of these packets, it will try to reconstruct the original packet. These slides show basically how the game engine deal with this packet. So basically, it gets the packet from the network, it processes the position and LAN, and then it places the data inside the buffer or memory allocated in the process. So this is how it's supposed to work. If you ever check this kind of functionality in some game, this is how it actually works. So instead of placing the packet inside the allocated buffer, it will place it just to some location in the memory, in the server memory. So this problem is related to the fact that basically the game engine trusts the position and the size provided inside the packet. So basically we can basically override arbitrary memory location with arbitrary data. And this is not just something, in theory that is like that. We can provide you some real-world example. One of them is given by the source engine, which was affected by this kind of vulnerability. And since this was an issue affecting a game engine, was actually affecting several games like Half-Life, Counter-Strike, Team Fortress, and so on. So when you have this kind of vulnerability, it's not just easy, to override memory region. It's actually very easy to take control over the process. The point is that usually this kind of engine are written in C++, so you have hundreds of function pointers around. So you can just, if you add the UDP packet, override one of these pointers and take control over the execution. So this kind of issue affects even not only game engines, but even game libraries or specific games. And this is an example. If you're an attacker and you are looking for additional targets or additional victims, you should know about the master servers. Master servers are a sort of online database for games. They're used by players to find games from game developers to implement in their software matchmaking functionalities, and they are even useful for attackers, because by using this kind of servers, you can basically get the exact location of a specific target and know about the IP address of the target, the game that he is using, and you can basically target a specific user on the network. Okay, after that, we are going to cover the crypto and compression for games. We are not going to cover all the aspects of crypto and compression. We are going to focus on crypto and compression algorithms related to packets. So when we are dealing with games, usually they use a lot of this kind of algorithms. And basically we have two main approaches to deal with this kind of algorithm. The first one is to use tools that basically we run this tool and we know, okay, this game is using, RSA or another algorithm, so it's an easy game. The problem is that usually games tend to use a customized version of these algorithms, so usually tools are not enough. So in this scenario, what we need to do is basically use our eyes and try to go through the disassembly of the game. So what we do is basically look for patterns. Which are pretty obvious for, basically we have a loop with automata operation and things like that. But since we are dealing with this kind of algorithms, it's not easy when, we are dealing with customized version of known algorithms. So what we did is basically a sort of survey of, the most widely used crypto and compression algorithms for games. So we had this kind of result. We had that for crypto algorithms, the most widely used are RC4 and T, and for cryptography is zlib. But when we are thinking about, compression, it's not just related to algorithms. Compression is even related to structure. So if you're dealing with games, usually the data inside packets or memory or inside the game engine is not usually byte aligned, which means that very often we need to deal at bit level. So there are two main approaches to deal at bit level. The first approach is called bit streams, and basically this is widely used for streaming protocols. And the second one is called index numbers, and it's basically a way to represent 32-bit numbers without using every time 4 bytes. And this is really interesting for bug hunters because you can exploit feature of this way of representing number to find really cool and interesting behavior inside the game engine. So basically, we have 2 versions of these index numbers. The first one is a signed version, and the second one is an unsigned version. Let's take in consideration the unsigned version first. Basically, we are dealing with 32-bit numbers. So the idea is pretty simple. Instead of representing 32-bit numbers as a sequence of 4 bytes, we represent each byte as a combination of 7 bits plus 1 bit, where the 7 bit is used to hold the value of the number, while the last bit is used as a sort of next flag. Basically, if the number that we are trying to represent fits inside 7 bit, we just need to send 1 byte. If we need to send additional byte, we basically add another byte and we flip the previous last bit to 1. This is interesting because if you spot inside the game that you are dealing with this kind of strategy, you have to try to flip, play with the bits, especially with the last one, because you can get really interesting behaviors. This is not just something in theory, because this was actually used by games like, the Unreal Tournament series, based on the Unreal Engine. So they were using the signed implementation, which basically is the same as the unsigned. The only difference is that the first bit of the first byte holds the sign of the number. Okay, so if you're a player or like cheating and doing this kind of stuff, usually games have a lot of protection. And the point here is that these protections are not there, to prevent people from, finding vulnerabilities. They're there because they want to prevent people from cheating. But they are super annoying for, even bug hunters, because you have trouble to touch your debuggers. They detect if you mess with memory or you use, tools that you need to perform your analysis. But the important point here is that this kind of protection are not supposed to, keep away the bug hunters. These are just a sort of way that game developers use to keep kids away. But if we are bug hunters and we are looking for vulnerabilities inside game, we should consider this kind of protection as new opportunities to find new and additional vulnerabilities. And a very interesting example of this kind of protection is given by Punkbuster. If you know Punkbuster, it's a widely and well-known protection, which is supposed to protect video game and players. But there was a really interesting vulnerability affecting games like Quake 4 and Doom 3 that basically was not exploitable if the game was not protected by Punkbuster. But in case the protection was actually in use by the game, this vulnerability was very easy to exploit. So our last part of this trip will be focused on the game engine, and we will try to understand the core of the game engine. In order to reach the core of the game engine, we need to basically follow these 3 steps. The first thing that we need to be able to is basically to monitor the network inputs. If we are using a debugger, this means that you are basically setting breakpoint on receive functions, so you can basically trace when a new packet comes in. After that, you basically want to be able to trace the packet in memory, because you need to understand basically the data that is coming in, where it's going to. So our final location is basically to locate the game opcode processing routine. The game opcode processing routine is basically where all the functionalities of the game basically become alive, basically. This is very easy to spot if you're using a disassembler, because it's usually composed of a very huge switch statement, which has hundreds of different callback functions, where each callback is basically the handler of the given opcode. So once we reach this location, basically to find vulnerabilities, we can use 2 approaches. The first approach is basically we can write a quick fuzzer. So basically we are going to test all the opcodes of the game protocol itself. The second approach, which is usually the best one, in our opinion, it's just to use a disassembler and check each single handler in order to find common class of vulnerabilities, such as integer overflow, which are very common for game engines. This is because you can imagine all the math operation for graphic and this kind of stuff. For game, it's interesting to know that there are a lot of format strings vulnerabilities. So if you like them, you should check games because there are a lot of this kind of vulnerabilities. Since we are talking about games, it's interesting to cover just in one slide 3 of really interesting game-specific, almost specific issue. Since game allow us to perform customization, what we are doing here is basically try to force the game to load malformed map. This is very interesting because it's a really interesting way to find easy vulnerabilities, and this is due to the fact that games usually use very, very complex functions to deal with custom map. Another interesting and very nice way to perform a denial of service attack while using games consists in relying on fake players. A fake player is basically a piece of software that basically sends to the server fake players, which basically acts like real player. So their aim is basically to fill all the rooms available on the server so that real player will not be able to play the game. And these are really hard to prevent, and this is due to the fact that usually games are UDP, based on UDP. So if you try a solution like IP filters, they usually fail. Since games, usually we have a server and several clients, they have some sort of functionality that allows the server to send packets to broadcast a packet to all the clients, and you can basically exploit this kind of functionality to have a sort of very cool way to exploit the same vulnerability by sending just a few packets to the server, and then the server will basically forward for you think about an exploit to all the clients connected. Okay, so after that, let's take a look at the real world. So in the following slide, we are going to cover some real world example, including our new 0 days. First of all, so this is our agenda for this part. So basically, I will do an introduction on a vulnerability that we found in Steam a few months ago, and then Luigi will show you some demonstration on how to bypass some limitation of Steam, and he will detail our new 0 days. So if you don't know Steam, Steam is basically a huge digital delivery systems, and Steam has 54 million active users at the moment. And a few months ago, we found a way basically to exploit local vulnerability remotely by using Steam as an attack vector. So we are not talking about XSS, we are talking about remote code execution. And basically, to achieve this goal, what we did is basically we found out that Steam was using this protocol, which is called the Steam Browser Protocol, which is used by Steam to install and uninstall games, allow the user to play game online, and in a specific case to run games. So what we were able to do, basically, we found a way to run games, on remote system by using links on remote website. So in order to achieve this goal, we had to find basically 4 undocumented commands, which are the one in red here: run game ID, run save, and run game, which have the format here. So once we found this command, we had even also to bypass several protections. Some of this protection were related to the browsers because you cannot use very big strings. And some of this protection were related to Steam itself. Think about if your victim is basically using the game that you are trying to exploit, you cannot run again the game. Basically, you are limited to only one instance of the game running per time. So the attack plan was basically the following. So basically, you just need to pick one of the 2,000 games available on Steam. Then you just need to find a local vulnerability, which means something that you can exploit on your own computer. In order to find this kind of vulnerability, it's interesting because it's pretty easy to find very, very interesting vulnerability by just looking at the command line of the game itself. From the command line, you can usually do a lot of interesting things like, loading map, patch, configuration, logging, and this kind of stuff. So once you find, a local vulnerability, what you can do is basically trigger this vulnerability remotely by basically writing down a link like the one that we were showing before and load this link on a web page. So as soon as your victim will visit this web page, basically the exploit will run. So when we released our advisory a few months ago, we provided several fixes for users, team, and game developers. So if you think that this is something dead that you cannot no longer use because it's been fixed, you are wrong. Basically, this is still a huge attack vector, and Steam didn't fix this vulnerability because the problem here is that this is a design issue. So basically, if they want to fix this kind of issue, they need to rewrite basically the whole, most of Steam. So after our advisory, basically the only fix provided were related to the proof of concept we used, so Team Fortress and APB. But I mean, if you want to have fun and you want to try by yourself this kind of vulnerability, feel free to go on Steam and download one of the more than 2,000 games that we didn't test. And basically, you will find out that it's very easy to exploit local vulnerability from remote. Okay, so in this second part, Luigi will show you some demonstration and we'll show you our new 0 days.
Okay, now we're going to see some vulnerabilities and design issues affecting games and game-related software. It's important to note that these vulnerabilities are exploitable via web browsers. And additionally, they don't require anti-mitigation techniques. So, the first one is just Steam, the content digital delivery platform developed by Valve, and for which we released a paper in October of the last year. This platform allows to pass remote command line arguments to locally installed games via URI handlers. In one of our proof of concept video, we used a particular way to send multiple command line arguments in different moments to the same instance of the game. This is possible due to the hijack switch, which is a documented option of the source engine. Now, here you can see the original proof of concept we used for our video. So, there are 3 different Steam links. Each one contains a command line, and they are executed in 3 different moments. The first one just starts the game. Then the second one after 20 seconds, just to give time to the game to load, sets the log file to write, and in this case we opted for a bat file inside the startup folder. The last command instead will write the command we want to write inside the bat file, and then quits the game. Now, we are ready to see the first demo. This is just the one we released in October. Okay. So, here we can see that the startup folder obviously is empty. And this is Steam, the Steam interface. It's divided mainly in 2 parts. The first one is the store. The store is basically a web browser, an embedded web browser, for browsing the Steam website and buying games, downloading demos, and so on. It's interesting that in this interface in the store, all the Steam links are executed automatically, so no warnings and so on. The other part is the library, so the collection of our installed games. Now we go on the attacker website. This is just a simulation of a website. And we select the Team Fortress 2 proof of concept. Here we can see the first command, the first Steam link executed. The game takes some seconds to load. And then will be executed the second link in the background. that sets the bat file inside the startup folder, and then we write, for example, the calc command, so that will be executed the calculator, the Windows calculator, when the user logins on the system. Now, this was game-related software. While now we want to talk about a real game, and in this game, which is Battlefield Play for Free, we can see that it's a free multiplayer online web-based game. It's available since 2011 and has a very good community. Now, why it's a free web-based game? Well, basically it's just free, so you can install and play it for free online without problems. But if you want maybe additional items like I don't know, a more powerful weapon, for example, you need to pay real money. And then it's a web-based game due to this reason, the one you can see on the screen. So you need to install a web-based plugin for your browser. This plugin is just one of the three components that compose all the game architecture. Here you can see there is also an updater, and then the game itself. Here we can see the first part of the interaction between all these components. The plugin exposes this start method to the browser, so any website can call this function. One of the arguments of this function is this CMD line, which is just a command line. This command line is used to launch, is used by the plugin to launch the updater. And then it appends also that host option followed by the website that called this function. Now, for this additional host option has a particular purpose. It's used by the game updater for checking that website is a whitelisted one, because not all the websites are allowed to interact with the game updater. But there is a problem. Create process W is a particular API. By default, it should terminate if the command line, the specified command line, is longer than 32 kilobytes. But there are some different behavior with the operating system of released before Windows Vista, so I'm talking about Windows XP and 2003. In these particular cases, the command line is truncated to 32 kilobytes, and the command is executed as is. Now, here we can see how we can exploit this particular behavior on, for example, Windows XP. Take a look at the slide. So, by increasing the number of the length of our command line, the one we provide via the start function, we can keep the original host option added by the plugin outside, and we can use our spoofed host option to allow our website to be to use the game updater. Now, the game has been released in 2011. It's based on DirectX 9, and so Windows XP and its 40%, about 40% of market share are a perfect target to exploit this vulnerability, the vulnerability we are explaining. Now, the game updater has a particular job. Obviously, it updates the game or installs it if it's not already installed. Then takes these four options provided by the plugin and use them to launch the game itself. But there is a problem. One of them, soldier name, is handled in a particular way. On the updater, the double quote delimiters are correctly handled in the updater, but the game isn't able to handle them. So we can inject our custom options through the soldier name. There is a particular interesting option in the game, and is this mod path 1. This option allows to specify a folder where are installed the game files that can be used by the game. And we have zip files and some files called con that are scripts containing commands that are executed by the game engine. This folder is an arbitrary one. So we can specify also a SMB WebDAV folder, a shared folder on the attacker. And those three commands you see on the screen are used to write a file in an arbitrary location of the disk. Then we use this game crash command for terminating the game immediately. So the user, the victim, will see almost nothing, just a flash, nothing else. And then we use the TFTP client, which is available by default on Windows XP, for uploading our payload. There are also some, small limitation obstacles in the usage of the three commands we have seen before. Because, there are backslashes converted in slash, and a limit of 1,000 bytes chars for line, then some chars are filtered, and so on. And, there are also format string bugs inside one of them. Anyway, we were able to bypass all these little obstacles, and now we can see the demonstration. Consider that this one is undisclosed and is presented for the first time here at Black Hat Europe. So here on the right you can see the victim. We have the startup and temporary folder that are currently empty, as you can see. We will use the Process Explorer to see the interaction between the various components. While on the left we have the attacker. So there are some tools that the attacker will use. One of them, is the payload. In this case, it's a reverse shell. The exploit program, the netcat, then TFTP and WebDAV server, and so on. The first step is just starting the exploit. The job of this little tool is creating all the structure of the folder we are going to share with the victim. Now we are launching it, because it's necessary to have a particular structure for the game to load our malicious file. It launches also the WebDAV and TFTP server. This is the content of the folder we are sharing with the victim. And as you can see, it contains the rank settings.con file containing our malicious commands. And now, obviously, we want to try to browse the attacker website from the victim. Now, pay attention to the time necessary to exploit this vulnerability. That's all. It takes just 1-2 seconds, just a flash of the updater. And as you can see, the bot file has been just created. We can also verify the content of the exploit.bat file. And so we see the TFTP client used for uploading, in this case it's downloading, the payload, and then we start the payload. Now we can see just the interaction and the time necessary for the exploit. So we just relaunch it. Okay. If you watch Process Explorer, you can see plugin, updater, and game. So this is the interaction. And as you have seen, the time is really very short for performing the exploit. Now we want to try our bat file and also the payload. So we launch netcat in listening mode so we can receive the reverse shell we are launching. Remember that the bat file will be executed every time the user will log in on the system. So now we just double click on it for making the things shorter. And as you can see, now we have full access on the victim host. Wait, don't worry. We have other stuff, don't worry. Okay, we like electronic arts, okay. So we want to give another present to them. Oh well. Steam is not the only digital delivery platform available. Electronic Arts started its own platform in 2011, and it's called Origin. Now, Electronic Arts has various reasons for having its own platform. As you can see, well, it's a very big, huge game developer and publisher. And well, in 2010, the company even reached Fortune 500. Well, not bad. Here we have just a little collection of some games or game series they own. Maybe you know Crysis, Battlefield, Need for Speed, that I like, Need for Speed. Then we have all the EA Sports games, NHL, NFL, and so on. Dead Space, The Sims. Well, it's enough famous The Sims at the moment. Oops, for some problems. Now, Origin is very similar to Steam. For example, the interface, because we have also in this case the store and the library. Also for the users, because they are growing very rapidly, and so they are enough close to the number of the Steam users. But the most interesting feature that is similar to Steam is just this one. Also, Origin uses a URL handler and allows commands to be passed to local installed games. But there is even, how to say, a better feature of Origin, because you can specify multiple games on the same link. For example, a series of games that share the same game engine. So we wanted something cool for demonstrating this issue. And we opted for the most awaited and most recent game available, Crysis 3. This FPS game is based on the CryEngine, which is pretty famous in the gamers community for being very hungry of resources due to its high-level, cutting-edge graphic quality. And this engine is also used for benchmarking the most recent graphic cards. So, well, it's not, how to say, a coincidence that how to say, a benchmarking feature is the one we are going to use to exploit this issue. There is this Open Automate option, which is used to specify a DLL, in this case an arbitrary DLL, that will act as interface for the NVIDIA Open Automate SDK, which is embedded inside the game. It's also interesting to to note that OpenAutomate is not only used in Crysis. There are many other games on Origin that use it. An example is Battlefield 3. Anyway, remember that this one is an issue in Origin. So Crysis is not, how to say, is just a feature. And we, the attacker, use this feature plus the issue in Origin to exploit the victim. Here we can see just a little recap of the various steps necessary to exploit the issue. So we have the player, which is just browsing the web, and he arrives on the attacker website. Here you can see there is an Origin link. Consider that the Steam and Origin links are pretty common because they are used for many purposes, like installing games or adding friends or even joining servers. So there are many users, many gamers that have these links already set as automatically executed. The link interacts with Origin, and Origin starts the game with our command line arguments. At that point, the victim is already exploited, is already compromised. Oh well, it's time for the last video. Okay, here you can see the Origin interface, store and my library. These are the games I have on my account. Okay, I like Crysis. And now we start the browser. We go on the attacker website. We have just simulated a joint server website. Firefox obviously doesn't display information about the link, no details, nothing at all. Good for us. The game is starting. It takes some time, and I wait. Oh well, I guess this is not Crysis, so our DLL was correctly loaded. Conclusions?
Okay, so at this point, what about the future? If you're a bug hunter and you have your own wish list, you should think about MMO. This is because they have several features that are really interesting if you're a bug hunters. Think about, they usually use crazy network protocols. They have these huge and complex game engines, and they have, if you're an attacker, they have a huge player base, and they are, usually connected to credit card and other sensitive information. So if you are thinking about targeting this kind of games, you need to keep in mind two aspects. The first one is if you are testing the client side of the game, you need to deal with the anti-cheating techniques used by the game that nowadays they tend to be like rootkit solution. Think about the solution used by World of Warcraft. So they require some skills in order to bypass this kind of protections. And one of the point here is that usually to test this kind of game, you need to have a valid account. And in order to have this valid account, you need to pay a monthly subscription, or you need to have your credit card details in, so you have to pay. So if you start messing with the game and you're the debugger, basically your account will be banned and you will lose money. So you need to think about this point. The second important aspect here is that if you are testing the server side of the product, this is a big issue because usually 99% of cases you don't get the server, so you have only the client. And you have two options. The first one is to use an emulator, But the point here is that the emulator doesn't match one-on-one the internals of the server. So if you're able to find the vulnerability inside the emulator, it is very likely that it will remain an emulator-only vulnerability. The second option is up to you. I mean, if you want to hack online server, feel free to do it. But I mean, a few people will be, will probably go after you. So just 3 slides as conclusion. Playing online game is different than being safe. I mean, games are no longer for kids. They are an exceptional stealth attack vector, and they are getting very complex. And usually, the more something is complex and the more under, the security point of view, introduce new issues. And if you think that, new games usually are linked to credit cards, social network, they are really interesting attack vectors. So after today, we showed you that the Steam attack vector is still active with these, almost 60 million users. And after today, in our 0 day, you know that you can even use Origin to trigger, remote code execution on victim systems. So in total, you have almost around 100 million possible victims around the world. So if you are a user, you are a Steam or Origin user, beware of the links. So if you like this talk and, you want to learn more about this topic, feel free to visit these links. And we're going to release a couple of new papers on our website today, and we will probably put a link on our Twitter account. So, any questions?
We also think there is an attack vector for downloadable content as opposed to upgrade.
Oh yeah. You basically, yeah. Basically, you can use every functionality to exploit these kind of issues. Yeah. Any other question?
What do you think about Buster? Because personally, I've seen some articles that kind of prove it.
Yeah, I mean, all these kind of solutions are like rootkit-like. So yeah, they are pretty interesting because if you have vulnerability inside them, it's a lot of fun. Any other question? Okay, thank you very much.